Hi, my name is Ricardo Arevalo. You guys can call me Rick, Ricky, or you can refer to me as my fantasy football title, which is Professor Orbitrap. Most of you guys probably don't get that joke, but it's worth it, and we'll come back to it later. So I'm the director of the M-Class Lab. I just found out 2 weeks ago that none of my students knew what M-Class stood for, so it's not a very effective acronym. But suffice it to say that it sums up what we do, and everything we do involves lasers and or mass spectrometers. So what we do can kind of be broken down into 4 different phases. We use commercial systems, just like a lot of us do, to understand what's analytically capable. Can we derive 2D chemical images of lunar regolith with just the laser and just the mass spec without Richard Ashe's or Bill's 9,000 Kelvin plasma that takes over 1,000 watts to fuel? And we try to answer fundamental questions too. Which mineral phases offer the highest preservation potential for organic material that may be indicative of early life on Earth, ergo early life on another planetary environment. The second phase that we kind of migrate towards is using lessons learned from those commercial applications and trying to shrink down that technology, because we're not going to send a 200 kilogram instrument anywhere in the solar system. If we're successful in those 2 phases, we shrink it down so effectively that we can qualify it for space. And by that, we put it on a vibration plate, make sure it can survive a launch load, just like Artemis, if it launches. Make sure it can survive the thermal extremes in the environment that we're trying to send it for, make sure it can survive the radiation, etc. And then finally, maybe the most fun thing we do, if we think we have a technology that can answer major science questions, we think we can ruggedize it sufficiently to get to that planetary destination, we can contribute to and define our own mission concept studies. So this is one of the coolest things that we did. We proposed a package, a payload, to send to the lunar near side. We proposed this last year. It wasn't awarded, but we're going to repurpose it for another mission opportunity, but to investigate questions such as, what is the rate of exogenous organic delivery to the lunar surface? What are the rates of space weathering in the lunar regolith? And is there a chemical link between 2 different lithologies on the moon that are particularly weird? Thank you.